Hi everyone, this is the solution for set 2 of questions, so involving op amps. This is question 3, so we assume an ideal op amp for the following circuit. And first we need to find the output voltage, V0, and then what's the input impedance or resistance, Ri1, as seen by the source V1. So just this is, I think it's a preview of the question, so I'll call this one here view1, okay, this one here, yeah, so this one here, view1, and this one here v2, so it makes sense that we have IR1 over there, okay. So in this case, because we are considering ideal op amp, remember that for an ideal op amp we have an infinite gain, an infinite input resistance here, right? Not the input resistance is from the source, and zero output resistance here inside the op amp. Okay, so those are the conditions for an ideal op amp. And then because we are considering that, we know that for an ideal op amp, the currents entering the inverting and non-inverting inputs of the amp, they are equals to 0. So what does that means is that there's no current entering here and no current entering here. Okay. Another assumption for an ideal op amp is that the voltage at the negative or the inverting input is equals to the voltage at the non-inverting input. Okay, so those are the two assumptions that we have to do our circuit analysis. In this circuit especially, we have a weighted summer, so in this case we know that first the voltage at V plus here is 0 volts, right, because it's grounded here, so there is no current because of the ideal amp op, so that means that's no voltage drop across this 4k ohm, and indeed we have 0 volts at the non-inverting input, which implies from this condition here that we also have 0 volts at this node here, the inverting input. Okay, so in this case we could treat this as using superposition as like an inverting amplifier for the first input, and then we add with the second input. But the relationship between output and input for this particular circuit is that minus, okay, and then we have 10k, which is the feedback resistor here, 10k divided by, so for the first input this 5k here, times the first input, okay, plus the feedback resistor again, 10k divided by the 2k over here, times the second input. Okay, so that's the equation for the output voltage. Okay, so in this case, if we substitute the values of V1, sorry, here should be V1 and V2, we get a V out here that is equals to minus 2 times V1, which is 8 millivolts, plus 5 times V2, which in our case is minus 4 millivolts, right? And this gives us a V out, so this is part 1, right? This gives us a V out, so 2 times 8 is 16, plus minus 20, which is minus 4, minus here outside the parentheses gives us 4 millivolts, okay? And that's the voltage at the output. So this 4k here, it doesn't change the analysis, and those 3 and 2K here, they're basically the loads that that are basically loading the output of the amplifier, so it doesn't change the voltage at the output. That's one of the advantages by using operational amplifiers to build a amplifying circuit. So in this case, we just have to take care of the feedback loop and the input resistors that we have on each one of the input sources. Okay, so the second part is that what's the impedance seen by the source VI1 in this setup. So let me just erase some of these nodes here. Actually, here it's still 2 and here it's still 1. So it asks for this input resistance 1. Okay, so the input resistance is the resistance seen from the voltage source. So basically the equation that tells us what's the resistance seen here. So if we say that we have I1 here flowing this direction, this is V1, right? The input that we have. So let me put here as part 2. So for part 2, the input resistance R in 1 is actually the ratio between V1 and I1, or V input 1 over I1. Now if you remember, we had 0 volts here, right, because of the ground here. So the voltage V1 is actually, the current I1 is actually equals to V1 minus 0 volts divided by 5K. So if you rearrange this equation here, we can get the input resistance, because here we have 0, right? So it's just V1 divided by I1 equals to 5K ohms. So that's the input resistance for this particular circuit, and I think that's basically all the solutions that we have for this particular problem. Okay.